So when we fill out the chart then of the doubling prism, we start with our original prism, which we were going to call 6 units, and it doubles, so we're going to have 4 times the area, surface area. When we double the length and width and height, we go from 1 unit of volume to 8 units of volume. So our surface area to volume ratio goes from a 6:1 ratio of surface area to volume to 24:8, or reduced is going to be 3:1. So when we double the volume, or sorry, double the length, width, and height of any object, we're going to make the surface area smaller by a factor of 2. So we went from 6:1 to surface area of 3:1. Okay, so that doubling changes the surface area to volume ratio. We have less surface here for the same volume when we talk about a small prism, okay, versus a larger prism. Okay, when we have a larger prism, we double the length, width, and height. This has less surface area for the same amount of volume as we would have here. Okay, so this surface area to volume ratio changes. So bigger objects have less surface area to volume ratio. Okay, although they have more total surface area, the ratio of how much volume that is inside, okay, there's going to be less surface for each amount of volume. That kind of makes sense, because if you think of each individual block here, well, you can fit those blocks into here, and you can see that some surfaces of this block are going to be covered up in this one. So we're going to end up with less surface for the same amount of volume.